Hello all. In this video we're going to take another look at lists and strings. This was a data type we've seen before. We've looked at their operators and operations and functions. Today we're going to add string and list methods, but in this video we're going to focus on reviewing the string operations and the list operations that we've already seen, reminding you of how they work, and introducing a few important concepts about strings and lists and this kind of complex data types in general. All right, so just to remind you of the things that we have seen before. We have seen a few functions that operate on lists or strings. Generally, the len operator works on many different data types, happens to work on lists and strings particularly, and len is short for length. It will tell you how many elements are in the string or the list. So if it's a string, it tells you how many characters are in the string. And if it's a list, it tells you how many data elements are inside the list. We also have seen the functions list and stir, which allow you to convert data from some other type to being a list or from some other type to being a string. They're very helpful things to have. We have also seen with lists and strings that they are zero indexed. So if we want to access those elements that belong to them, the characters or the annual data elements for a list, we use the same notation. So we use a square bracket, and if we want just one element to be pulled out of the string or the list, we just put in an index here, and it will give us that one element. But we also have slicing, which is where we want a section or a subset of the data or characters, and that's when we give it use the colon notation inside the square brackets, and we'll do some examples of these in a little bit, and it gives you a region. So in this case it would give me from the character at position 0 in my name up to but not including the character at position 5. A little trick you can do with this, if you don't have a step size specified, if you subtract the start from the end, that'll tell you how long this resulting substring or sublist will be. So we have already seen those and worked with them a little bit. It's probably good to go over them again. We also have seen two operators that operate on lists and strings. Plus takes two strings and puts them together, concatenates them to make one string, has the characters of the first immediately followed by the characters of the second. And then if you have two lists, you can use plus and it will put them together to make one list that contains all of the data. The star, the times operator, is a little more unusual, and we'll look at some examples of that in a bit. It takes a number and a list, or a number and a string, and it repeats the string, concatenating the string with itself that number of times, or concatenating the list with itself that number of times. It's a very powerful and helpful operator, but it's a little cryptic in how it works. All right, there's some key ideas here, this idea of immutability, and that's one that I really want to focus on. We haven't talked about this too much, but now is a good time to come back and think about it because it actually turns out to be important as a programming concept. So we call a piece of data immutable if you can't change its contents. So mutable means, like, think of mutation. It means it's changeable. Immutable means it is unchangeable. So if we build a string, strings are immutable. Once you've built that string, you can't modify a character. You can't change a lowercase to an uppercase character and keep the same string. The only thing you can do is to build a new string that has the changes that you want. So strings are immutable. Tuples, which we've also seen before a little bit, tuples are also immutable. Once you build a tuple, you can't add one to a piece of data that's in the tuple and have the tuple changed. The only way to get a changed set of values in a tuple is to pull the tuple apart and put it back together again with the new values. By contrast, lists are mutable. They are changeable. I can build a list, but I'm allowed to go and change the data that's in that list at any time. This is powerful and useful for us. It has a few downsides, which is why we have other data types that are immutable. All right, I'm actually going to use an in-class activity here. And we're going to review with a couple of examples some of the things that we have seen before. So I've already talked about most of these operators. I'm going to do a few examples. So let me just switch over to PyCharm so we can do some Python examples. So we have these string operations that we've used before. I'm going to make a couple of strings. So S1 is my first name. S2 is my last name. And I'll just make a string. Now this one's more complicated. It has spaces and commas and other things like that. So what are the various things that we can do with this? We can access individual elements. So I could print things like S1 sub 3, S2 sub 0, S3 sub 15. I think it's long enough for that. And remember, we have the negative numbers as well. So what I'd like to do is let's think this through and see if we can predict what this ought to print, and then we'll actually try it out. So S1 is Susan, position 3, it starts with 0. So capital S is 0, 1 is U, 2 is S. So we should get an A. S2 sub 0 should be the F. S3 sub 15, oh, I hope it's 15 long. I'll have to change this otherwise. 0, 1, 2, 3, 4, space is 5. 6, 7, 8, 9, 10 is another space, 11, 12, 13, 14, 15. So we should get a P for that one. And then negative 1 is the end, so it should give us the X. It goes from the right end backwards towards the left. So what I'm going to do is just run this, and we'll see what it does. I may have to adjust my window just a little bit. Yes, I'm going to have to. Okay. So you can see A, capital F, P, and X. I correctly predicted. Well, I should. I know this stuff. Were you able to correctly predict what was going to be printed? Try a few examples on your own if you're not sure how these work. Okay, reminder about slicing. I'm going to do a little bit of slicing on these. So I'm going to say S1 sub, stop that, S1 bracket. And then I'm going to say 1 colon 4. So again, using my little trick, 4 minus 1 is 3, so it should start at position 1 and give me 3 characters. And I'm going to do a few other examples. S3 sub, let's try 11 to 20. For S3. And then I'm going to do one where we skip characters. So we will do S1. I need something that's slightly longer. Colon, colon 2. So it'll start at position 0, and it'll go up to the end of the string, skipping every other one. If you remember with the slicing operator, if you don't put in a value, it chooses the start of the string, or in the second position, it chooses the end of the string. Unless you put a negative step size in, and then it does it slightly differently. All right, so let's just run this and see what the results are. But think this through, maybe even pause this video, try to figure out what the correct answer would be, and then unpause and see what happens. Okay, so USA, that was what I should predict for this first one. And then we looked at the third string, and we printed 11 through 20. That printed trapped. That worked out better than I had actually anticipated. And then we have, here we have this S1. Oh, yeah, trapped. There's an I here. Trapped, and the I, that's actually position 20. And the third one printed from the 0 to every other. So the S and the S and the N, which is this SSN. Now notice I'm using commas in the print statements here. that causes Python, it automatically puts a space in between them. Sometimes that's a little awkward because we can't quite tell where the beginning or end of these different strings are. I could print them each separately. That's probably the easiest thing to do, just so that I can tell exactly what is part of each string. I will sometimes also tack on something at the beginning or end. So I'm going to tack on an angle bracket at the front of this string using the plus operator and an angle bracket at the end. And that'll just, anything in between the brackets is what actually was sliced. So sometimes that's helpful to be able to see what's actually happening. So you can see trapped space I, that was 11 through 20. All right, so that's string slicing, string access. We've seen these operations before. Multiplication is the one that I want to come back to again. So I'm going to comment these out, and then I'll add some more up above, just so we can keep seeing what we're doing. So the multiplication operation, I like to put spaces in here. Python doesn't care. The multiplication operation takes a string and it takes a number, an integer. And it's going to repeat this string as many times as this number says. So when I do this, it should print Susan 10 concatenated together with no spaces 10 times. Oops. And similarly, if I print string 2 5 times, it should say fox repeated with itself 5 times. And sure enough, I could count them out. I trust it. It's going to do it the correct number of times. This is something we do kind of for fun at times, but there also are times like, suppose I wanted to print a long horizontal set of dashes just to set off my output. I could just type that in. So I could do something like this, and just hold down the key and let it type repeatedly. But I could also do that just by using the multiplication operator to make something that's a repeating pattern. And the nice thing is that I know exactly how long it is too. It's hard to count when you're just holding down the space bar exactly how long you're making that string. This I know is exactly 40 characters long. So that's the multiplication operator. If I go back just for a moment to Chrome, in addition, there's one other operator I haven't talked about yet. I haven't shown you the len operator, but there's also the in operator. And this is used with Boolean, if statements and things like that. It is a Boolean operation. So it lets me ask questions. So I'm going to put an if statement in here just to see how things look. So I will say if m in S1, then print, oops, I'm going to finish this thought, print string 1. Notice that I have a little problem here. I've got a red marker over to the right, and there's an M underlined here. It doesn't know of a variable named M, and I actually meant that to be a string, so I need to put quotes on it. Quotation marks go where you want literal strings, things that look just exactly like what is inside the quotes. If you're talking about a variable, we don't want to put quotes on it because its name is fine all by itself. We mean the variable. All right, this is a good chance to also think about conditionals again. I'm going to move my other example down a little. Okay. So here I have an if-else if, an if-elif statement. I'm looking again at these three strings and I'm asking, is there the letter M in them? If M is in S1, then it will print string 1. If M is in S2, it'll print string 2. If it's in S3, it'll print string 3. What should it print? It's right up here at the top. Right here. It prints string 3. I hope that makes sense. But I want you to notice one thing. If I had put a capital M here, I would not get that result. In that case, it prints no strings. Capital M and lowercase m are different characters, and so they are treated differently. All right, so these are the basic string operations. I want to show you basic list operations as well. So I think I'm just going to scroll down here and talk about that. Well, delete this last piece. All right, the last thing I want to do before moving on to list operations is to remind you of looping over strings. I'm going to uncomment this. We'll just keep everything. So sometimes we want to go through the characters of a string. One thing I might want to do is, there are actually easier ways to do this, as I'll show you in a little bit, but I could do something like count up how many of the letter I there are in a string. Well, let me pick something that's a little more common. E. Let's pick E. So I could write a loop where I loop over the characters in a string. So I'm going to use S3. That was my longer one. And I'm going to put an if statement in here at first. I'm just going to say if E equals CH, then print E. Now, this is one of our two forms of for loop, and it's a very useful one. So S3, was that what I called it? Yes, S3 is help I'm trapped in the computer. And when I write the for loop this way, with S3 as the only thing after the word in, it's going to go through every character. So CH will be the capital H first, and then the lowercase e the next time through the loop, and then the L, and then the P, space, and so forth. So this is going to be a string that's only one character long. So I'm asking it just to print something every time it encounters an E. I can try running that just to see what happens. You can see E, 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 E. Does that match? If we go back up and look at the string, there's an E here, there's an E there, there's an E there, and there's an E there. So 4 E's sounds about right. So this is a really simple kind of a for loop. I could add an accumulator variable here. Maybe I will, just for the sake of showing you the example of an accumulator. So count E is going to have 0 initially because maybe there are none. But every time I find one, I'll add 1 to it. I know I've mentioned this before, but I'm going to mention it again. This is, you can write this out and it's very easy to read like this. There's also a shorthand. So you can say count E plus equals 1. And what that says is add 1 to E and save it back into E. It kind of is just a condensed form of exactly the same thing. All right, so if I run this after this whole thing, I'm going to print count E. It's a really good idea not to just print a whole bunch of pieces of data, but to label them. The number of E's in S3 is. But to actually like put descriptive strings in your print statement so you can tell one print statement from another. There. So yeah, there are 4 E's. I also want to note that there is another form that you could have here. I'll do the shorter version. So I could say for I in range of the length of S3. This is the other common form of for loop that we do. When we use the range function, then we know that this loop variable is going to be a counter. It's going to start at 0 or wherever the range function says to start, and it's going to count upward or downward as described by the range function. So When we want to loop through, say, the elements of a list or a string, we often will do this particular form of a call to the range function. We say range, parenthesis len, parenthesis data, in this case S3. What does that do? Well, len of S3 is the length of S3. And this says, range of that says loop over the numbers from 0 up to the length of the string. Those are exactly the valid indices, the valid ways to index characters in the string. So it's another way to do what we did before. And the only difference is when you want to reference the characters in the string, you have to type it as S3 bracket I. But again, this is a really strong pattern. The first one I did is a common pattern. This is another common pattern. So this for loop, I haven't added the accumulator to it, but it is otherwise doing essentially the same thing as the first one. The only thing that is different is exactly what I do with the for loop, and then how I refer to the data that's in our string in this case. Okay. At this point, we're going to shift a little bit and we're going to talk about basic list operations. I will shift back here to our in-class activity. Actually, these are not in my notes document. So up here you see another set of simple examples that illustrate the list operations that we've learned so far. And what I want you to notice is that these are essentially identical to the string operations. Lists and strings are different kinds of data, but they are both sequences. They both are basically a row of something. Lists are rows of any kind of data. Strings are rows of characters. And so we use the same set of operations. That's helpful when you're learning which the operations are, because you don't have to learn two completely different sets of operations. It can be confusing if you are jumbling up in your head when you're working with a string and when you're working with a list. So we have len, we have plus, we have the times operation just as before. I'll do a couple of examples of some of these just to remind you of how they work. So I'm going to make a list of numbers. Oops, sorry, I need to switch over to PyCharm for a moment. I'm going to make a list of numbers and a list of words. I don't know, thinking about a barbecue. So cat, key, knife, and charcoal, those are all strings. I have a list of strings, and I also have a list of numbers right here. So we index them in exactly the same way. I can do the same sorts of things, and what I do is I get a list back if I do like the slicing operators. So I can say lst1 sub 2, that's just an access, lst2 sub -2, lst1 sub 2:5. I'm going to do a separate print statement for a special form that we do, lst2:2. Okay, so in the first line I just showed a couple of accesses. This is the one that's at position 2. -2 is counting from the right. That may actually is 0, 1, 2. No, they're not quite the same. 0, 1, 2 should give us 81. -2 gives us the position is here, so it would give us 3. And here I'm saying give me from position 2 up to position 5 in list 1. Oh, sorry, -2 would be knife because that was on LST2. List 1 from 2 to 5, 0, 1, 2, it's going to start at 81, and it's going to go up to, but not including 5, so it should include everything from there to the end. The second line, I wanted to show you this because it's a nice pattern. If you want to take a single string or list and split it into two pieces, if you know the position where you want the split to happen, notice there's a nice symmetry to these. I did LST2 bracket colon 2, and then I did LST2 bracket 2 colon. That actually splits the list into two pieces at the position 2. So position 2 will end up in the second piece and everything that comes after it. And everything before position 2 will end up in the first piece. All right, so you can see 81 knife and then everything from 81 to the end for that first slice. And the next line I got cat and key and knife and charcoal. So it's a convenient little notation. That is actually one of the nice features that is the reason that we go up to but not including this number, is that this is such a nice pattern that we want to use it if we can. All right, I want to do one example with the multiplication operator just because that's the one that people find weirdest. So I'm going to take LST1 times 3 and we'll just see what that does. So this is LST1 times 3. So it takes all of the data and it sticks the lists together. So we have 3 copies of the data all in one big list. It's essentially, it's concatenation. It's the same thing that happens with strings. It's just that we're working with lists instead. All right, I do want to show you again, just remind you that the same kind of for loop patterns pertain to lists as well as to strings. So if I have a number list, I can say for num in list 1, print, let's do if num is greater than 2, print num. So this is similar to what I did before where I was printing E every time I ran across it. Or I could do this kind of for I in range of the length of the list. And then I use the LST1 bracket I as the way to access the data. Because the indexes, the positions are being counted by the counter loop variable. If you really, really find that ugly, and I do sort of start thinking that's kind of ugly, the first one's very elegant and you should definitely use it whenever you like. I could also split the difference here a little bit. So I'll make a third version of the for loop. And what I'll do is to say num equals LST1 sub I. So inside the for loop, I can assign a variable to hold the value from the list. And then I can just use that everywhere that I want to reference that value. All right. This is just really to remind you of how all of this works. Okay, we're going to stop there. This is pretty much what we've seen before. And I wanted to show it to you again just to remind you of the similarities between lists and strings. In the next videos, what we'll do is to take a look at the methods that lists have and the methods that strings have. And here is where the two diverge mostly. They have a few methods in common, but they are actually quite different as data types, and that really comes out when you look at methods and the different methods that each different data type has. So I will see you very soon to do that.